All right. Boy, I've been hearing people talk about the bright lights, and they are right. So it's very bright up here. I hope that we've all been challenged and inspired by what we've heard yesterday and today. Is everybody happy about what they've experienced so far? Yeah. Well, I'm a little biased, but I don't think we can have a conference on wonder without talking a whole lot about the universe. And we heard a lot from Dr. Karin Oberg yesterday and other speakers. And what a nice way to close out this conference by having an hour about the universe of wonder that we live in. Things like galaxies, black holes, planets, and life. So I'm going to use this hour to kind of walk you through a few of the discoveries that we're making in astronomy and how we might think about them. And so I'm only representing myself today. I'm not representing any organization or anything, so I can share with you some of my personal reflections from the eyes of science and from the perspective of faith, of my own faith as well. So let's get going. We do live in an incredible universe, and I like to start talks by showing this image, which is a picture of stars, which I hope you can see. It's the Omega Centauri star cluster. This is the core of a globular cluster of stars in our own Milky Way galaxy. And the stars here are very crowded together. They're closer to each other than our sun is to its nearest neighbor, at least 4 times closer to one another, and sometimes even closer here. Because we have outstanding telescopes now, we can see the detail in crowded regions like this that humanity was never able to discern before. So this is a wonderful use of technology to open our eyes to things we were never able to see before. You're going to hear that theme a few times in my talk. This was just a calibration picture taken from the newest camera that was installed on a famous telescope, the Hubble Space Telescope, back in 2009. And you can see why it's great to have a telescope in space, because if you were looking at such a crowded region of stars with a telescope on the ground, looking through our turbulent atmosphere to see up to the sky, the light would likely get blurred together. So you would just see kind of a fuzzy combination of light here. But if you can get above the atmosphere, which is turbulent and can blur the light, and the atmosphere can also filter out some types of light, then you can start to discern and resolve things like this, where you can differentiate star from star. And you can even then do scientific analysis, look at the spectrum of light from each individual star, and that tells you about its composition, and it tells you about its age. Most of the stars in this cluster are quite old. They're almost as old as the galaxy itself. So you can also see here, I hope, marvelous colors. Can you see the different colors? Yeah. Why don't you yell out to me some of the colors that you see? Outstanding. And those of you watching online, you were right on target too. Okay. There are many different colors here, reds, blues, yellows. If our sun were in this field, it would be like one of these little smallish, whitish, greenish dots. The colors represent different temperatures in the outer atmospheres of these stars. Which ones do you think are the hottest ones? Oh, that was supposed to be a trick question, but you're too smart. Okay, so, blue stars are pretty much the hottest ones here, but they're all hot. They're all stars. By having the tools of astronomy, we can see this kind of detail, and I hope you're also seeing how beautiful this is. To me, it's like a collection of gemstones. And in fact, we see beauty throughout the universe. In our galaxy, we can see regions like this where stars are still forming. That's my own field of expertise, is star formation. Here's a cluster of massive stars that have recently formed out of interstellar gas. Our galaxy has a lot of stars, but it also has a lot of clouds of interstellar gas. Most of it's very wispy and thin, but there can be pockets where these clouds get quite dense. And if there's a dense enough region, or pocket of gas, a core of gas we call it, within some of these interstellar clouds, that blob of gas can feel its own weight. So even though most of the gas is very turbulent, swishing around, if you get a little eddy that's dense enough that it can feel its own weight over and above the turbulence, it will collapse on itself because of the pull of gravity. And if there's enough mass, that collapse will be strong and the pressure in the core of that little pocket of gas will be very high. And as you heard also from Karin yesterday, that can ignite fusion of hydrogen atoms. Most of the gas is hydrogen. Hydrogen atoms will fuse together, create helium, and on down the line, some reactions that can even create heavier elements and release light. And so that's what a star is doing. It's a little fusion factory, creating heavier elements and also releasing photons of light. These stars have formed recently, and what does recently mean? Probably within the last few million years, and sometimes hundreds of thousands of years for some of the more massive ones. And then they're shining their light back to the surrounding gas out of which they formed, and they have winds that come off the stars that actually impact the surrounding gas, and eventually this radiation and the winds will blow away the leftover gas around this cluster of stars. But in this intermediate time, that process is carving out structure in the surrounding gas. And if you look in the lower left, you'll see some pillar-like structures. These are common to see in these regions where dense clumps of the remaining gas are getting inundated by the radiation and winds from the stars and carved into these column-like structures. And lower mass stars that take longer to form are still coalescing in these leftover dense gas clumps and pillars. So we see beauty here. The radiation from the stars is hitting that surrounding gas and ionizing it, and that means it's separating the electrons from the protons, and when those atoms recover, they release light in colors that we enjoy seeing. So when astronomers see a region like this, we say, like you, wow, that's beautiful. But we also say, wow, this is a clue that star formation is active and recent, because if it weren't recent, all this leftover gas would have been blown away. I didn't grow up doing this. When I listen to my bio, all I can say over and over is thanks be to God, because I didn't grow up in a community of scientists. My parents didn't have the privilege of even having a university education, but they really encouraged their children to have that experience. I grew up on a cattle ranch in a neighboring state to this one, the great state of Arkansas. Anybody know how to call the hogs, Arkansas Razorbacks? All right. Anyway, I grew up on a little family farm. We raised cattle, and so that's me out there on a cold winter day on the pastures of our farm. And I grew up not hearing about formal science, but just experiencing nature. We loved nature. These are some more recent pictures from that same farm that I love. And I try to get back there as often as I can. Every season is different. Every day is different in what you see in terms of wildlife and the animals, all kinds of animals. Foliage, streams, trees. And we had the dark night sky. So I appreciated many evenings going on walks with my parents, and sometimes our dogs would come along. And we were able to look up in the night sky and see stars. And about the time I was growing up, NASA was sending these probes out to the outer planets, the Voyager probes. You remember those? And they were sending back the first close-up pictures of the outer planets in our solar system and their moons. And I thought this was just an amazing accomplishment of humanity, to send probes where people could not go and take close-up pictures of exotic worlds like Europa and Io, these moons around other planets. I still think the same thing. We were also growing up at an age when a lot of science fiction about space was coming out, Star Wars and such. And I was thinking about space a lot. So I wanted to be a part of that space exploration enterprise, but I had no idea how to do it. I will say that I was really blessed by encouragers from all around me. My older brother, who'd been the first one to kind of go off to college, and then he went on to become a scholar in economics, but he loved science, and he encouraged me to think about science as something I could do. And he and his wife would always give me sort of science-oriented gifts at Christmas and things like that. And I think that encouragement kind of opened my eyes that, hey, I can do this. This is interesting, different kinds of science. And my love of nature is a natural bridge to the study of science, which is the systematic study of the natural world. I also had, thankfully, a family that, even though we didn't have a lot of experience with higher education, my parents and family, as I mentioned, my brother, but also my parents, were really encouraging for me to go on and try whatever I wanted to try, even if it had not been done by anybody we knew before. So I was able to go on and apply for colleges kind of off the usual beaten path, and I'm thankful for that. Teachers in my public high school were really helpful and encouraging and dedicated. And so I think I grew up in those schools with a sense that if I didn't know something, I could learn it. If I didn't understand something, I could work hard and find out about it. You know, that kind of positive self-confidence that teachers gave, which I'm forever grateful for. And the church community I grew up, we didn't know much about science formally, but we knew that this is God's creation that we live in, and we sang hymns of praise to God, and it was natural to think of science as a positive thing, a way to study the details of God's creation. I learned a sense of humility about the Bible, that the Bible is God's word, but doesn't tell us all the details about how the natural world works, and science is therefore seen as a gift. So I think that sense of humility and encouragement helped me as I branched out and started going to study science formally. As you heard, I studied physics as an undergrad because that's a basic science you can apply to all kinds of engineering and physics. And then I went on, I took a couple of courses in astronomy. I found it interesting and applied to graduate schools and went on and studied astronomy and learned formally what astronomers actually do. Let me see. So, what do astronomers actually do? Well, we don't, in the professional realm, we don't actually sit outside on cold, dark nights and look through telescopes with our eyes anymore. A lot of people do have their own telescopes, and maybe some of you have your own. And I applaud you, because people nowadays can have in their backyards telescopes that were much better than the professional telescopes I used years ago in school. It's gotten that good. I was learning how to do astronomy when I went to Lowell Observatory, and we were still using glass plates to take images through the telescope and mechanical devices to measure where the objects were. And it was on one of those training camps that I unexpectedly discovered a comet on one of these photographic plates, where I was supposed to be finding a bunch of asteroids, but I found this other object. And I say thanks be to God, because that gift became my senior thesis. I studied that comet, and I really needed a topic. My prayers are not always answered so spectacularly, but this time it was. And then here, decades later, you know, it is continually mentioned, and I'm so grateful. It reminds me that of all of God's gracious gifts to us in our lives. So we use different types of telescopes, and here's some examples here. We have telescopes in space. The most famous one on top there is the Hubble Space Telescope. It's in orbit around planet Earth right now. It's been up there for over 32 years, and it is working very well right now. So we've had astronauts return to it several times over the decades and repair things or put in new instruments. So we're very happy with Hubble. There are other telescopes in space that do things Hubble cannot do. They see different kinds of light. They're up there for different kinds of science. So there's a whole fleet of space telescopes that have come and gone. And in the lower pictures there are some examples of telescopes on the ground. The Keck telescopes there on the lower left, on the top of what we hope is a dormant volcano in Hawaii. And on the lower right, the ALMA array of radio telescopes that pick up millimeter and sub-millimeter wavelength radiation. You also heard that from Professor Oberg yesterday about ALMA. So these are examples of facilities that are very professional quality. And so you might ask, well, why do we need these different kinds of telescopes? And it's because they each have a different niche of what they can achieve. They see different kinds of light, or they see different fields of view, or they're designed for different kinds of quickness in terms of pointing to different objects in the sky. Some of them see the northern hemisphere, some see the southern. In space, that doesn't matter so much. Different kinds of telescopes provide different complementary information. So that's why astronomers typically are studying some phenomena like a galaxy or a planet or a star system, and they'll use 2 or 3 different kinds of telescopes to gather the data and then do the analysis and write the results in a professional journal. Here's a picture of some of the dramatic servicing that astronauts were able to do on the Hubble Space Telescope while we still had the Space Shuttle operating. And that's been just key to keeping the telescope new, fresh, and operating all these years. We also have a fantastic crew of experts on the ground. So even though we don't have the Space Shuttle program operating right now, when we have little glitches and things on Hubble, we have people on the ground who are able to do marvelous work, to do workarounds just from commanding from the ground, even though we can't go up and open the hood right now. All right, you may have heard of this. A little over a year ago, another of these major space telescopes was launched. The James Webb Space Telescope was launched on Christmas Day. A little over a year ago, and there you see some both happy and anxious NASA officials in the lower photo watching the launch from South America. The Webb telescope is complementary to Hubble, and it's different from Hubble. The Webb telescope has a bigger collecting mirror cut up into segments so that they could fold it up and stick it in the rocket for launch. It's got to be kept very cold, which is why there's those layers of sun shields you see at the bottom there. And it sees infrared light. The Hubble telescope sees visible light, like our eyes can see, and energetic bluer than blue light, ultraviolet light, and a little bit into the infrared, the redder than red. Webb sees much deeper into that redder than red part of the electromagnetic spectrum, and is very sensitive and is much farther away from Earth. It's beyond the distance of the moon. So it is kept there and kept very cold and is operating very well right now. There it is as it was being put together in the clean room of the Goddard Space Flight Center where I work. So it was a very exciting process that took many years to build every component of this observatory that's now in operation. And I hope you're already seeing some of the fantastic images. I'll show a few of my own. Okay, so here we are back to the core of our beautiful star cluster, again, enabled because of the space telescopes and the professional telescopes that we have now that enable us to see things to this detail that we would not otherwise be able to see. And what we see is truly awe-inspiring. We do live in a universe that's incredible, and it inspires wonder and awe. And so for the bulk of this talk going forward, I've decided to categorize different ways that we observe or different things we notice about the universe. So I think there's about 9 categories that I want to go through here. So I'm going to say the universe is something and show you some examples. And then, how do we respond to this? There's no right or wrong answer, but I'm going to suggest some ways that we as human beings respond to what we're learning and what we see. And you may have different responses, and I'd like to know what they are. All right, so let's get going here. I'd like to posit that the universe is beautiful. And, you know, we can all have a philosophical conversation on, well, what exactly is beauty? How do you know whether something is beautiful or not beautiful? And there could be differences of opinion on that. But nevertheless, I think what we're seeing, such as the stars I just showed you, most people would say that is incredibly beautiful. Here's one of the new images from the Webb Space Telescope of the Carina Nebula. This is that interface between where massive stars have formed off the top of this image, and the light and the high energy photons and the winds from those stars are impacting the edge of the surrounding interstellar cloud. And down buried in that cloud, newer, lower mass stars that take longer to coalesce are still forming. And you can see the beautiful interface and those pillar-like cones that are being carved out all along that interface region of the interstellar cloud. It looks almost like a vast ocean. I wish I could take a surfboard and go and surf across it. It is quite beautiful. Here is in our sister galaxy. We have a few little galaxies right around the Milky Way, and one of them is called the Large Magellanic Cloud. And here's a couple of beautiful regions in that cloud. The top one is one of these star-forming regions where the stars that have recently formed inside are, just as I've described, both lighting up and ionizing the surrounding gas and also carving out structure. So it's quite amazing. The lower left thing is really just one major massive star, a type of star called the Wolf-Rayet star that ejects its outer atmosphere episodically. So you see this kind of donut-like thing around it from a previous hiccup. And all of this is to show you not only the beauty, but the activity that we live in an active universe that is incredible to watch. This looked kind of like an ocean scene, so it was given the nickname the Cosmic Reef. For any of you who snorkel or scuba dive, you might see some similarities here. Galaxies are beautiful. Galaxies are collections of some of these things I just showed you. Stars, hundreds of billions of stars, interstellar gas clouds, such as I've showed you, some of which are dense enough to form new stars, and a whole lot of dark matter that you don't see, but that's interspersed in the galaxy. There's so many stars, something like 200 billion stars in a galaxy like this, that the light all kind of blends together in the center. And if you look carefully in this beautiful image from the Hubble telescope, you can see some background galaxies in the background of the image that are just as spectacular. Now, we cannot get all the way out of our own Milky Way galaxy far enough to look back and take a selfie. So we have to kind of learn from within the disk of our own Milky Way galaxy, what it's like and where we are. And this is our best guess. It's an artist's impression based on observations of our own Milky Way. And so if you think of it kind of like a flat, thick pancake, where in that plane of the galaxy there's lots of stars and they've taken on this structure of spiral arms. And then our sun, if you look toward the bottom of this image, you can see something that says our solar system. So our sun and the planets orbiting it are down along one of the spiral arms, which is called the local arm or the Orion arm. And so, and this whole arm, just like every other star, is orbiting around the center of the Milky Way, which is so bright there because there's so many stars in the center of our galaxy. What you don't see buried in the center there is a supermassive black hole that we now believe inhabits the cores of most and maybe all galaxies, which is basically a repository of mass. Old stars and material eventually spiral in and accumulate in the cores of galaxies, and they take on enormous masses that then squash due to gravity into very small volumes. And that gravitational field becomes so strong that even light cannot escape. But light and objects around the black hole can orbit and also be very bright. So we can see the regions around supermassive black holes. So we're down there right now, orbiting around that spiral arm. Can you feel it? Do you realize that's where we are right now? And galaxies are just gorgeous. If you can look at some of these on the web, you'll see even more beautiful detail. So here's a quintet of galaxies called Stephan's Quintet. This is the image of it taken with the infrared Webb telescope. And so you can see these galaxies, several of them are actually interacting with each other. They're close enough that they feel each other's gravitational pull, and that's pulling some of the material off of one and toward and into a neighbor. And that can actually, that flurry of activity can actually incite turbulence in these clouds, which can start some of the star forming process in galaxies or invigorate it. So we see beauty, we see activity. How do we respond when we see this kind of thing? Well, I hope you have a sense of awe and wonder. But I think, at least for me, I also respond with a sense of joy. You know, how wonderful to live in such a beautiful universe. And then for people, many people of faith, it's a natural reaction to have a sense of praise. And I hope you do as well. Certainly the psalmist did. In Psalm 19, the psalmist wrote, "The heavens declare the glory of God, the skies proclaim the work of his hands. Day after day they pour forth speech. Night after night they reveal knowledge." And yet, they actually have no speech. They don't use words. No sound is heard from them. And yet somehow their voice goes out into all the earth, their words to the ends of the world. In some translations, this is numbered a different psalm, but the point here is that the psalmist was looking up at the heavens and recognizing that there's some message that the heavens give to observers from all over the world without using words and language. I still feel that's the case, right? It doesn't matter what culture you are in, what language you speak. When you see these images, or if you have the privilege of still having a dark night sky and look out, you have this sense that, wow, we're part of something amazing. Maybe we don't quite know what it is, what it means, but we know that there's something about the universe that is transformative to the way we think about ourselves. And the psalmist here would say that in some way the heavens declare the glory of God. All right, next category. The universe, as I've already pointed out in a few ways, is active. It's not stagnant. So, many people kind of casually recognize that there's some stars out there somewhere and a moon and maybe some other galaxies. But don't think about it much more than that. I hope that's not the case for you. It's certainly not the case for me. The universe is not stagnant. It's active. So what are some examples of this? Well, I hope you recognize this region of the sky. This is a region taken with a telescope on the ground that has a much wider field of view than some of our space telescopes have. And so you can see this whole constellation, this whole arrangement of stars that's very familiar to many of us. Anybody know what it is? Orion, yes. And so if you go out and find a dark place, you can see this constellation, especially in the winter. And I showed this picture once at a talk I gave in Australia, and the audience told me that it was upside down. But it's recognizable no matter which orientation it appears in the sky. And you see the bright star Betelgeuse in the upper left and the bright star Rigel in the lower right. Betelgeuse is an unstable red giant star that should explode in a supernova as it runs out of fuel anytime now within the next few 100 million years. So we're watching. If you take binoculars out and look at Orion, some of those stars in the middle, even without binoculars, if you're in a dark place, you'll see that there's a fuzziness to them. And astronomers call anything fuzzy a nebula. So there's a nebulous material around some of those stars in the middle. I always thought when I was growing up and looked at this that this looked like a kite in the middle with, you know, the kite part and the kite tail below. So, you know, constellations are not set in stone, right? They're culturally bound, so you can invent your own constellations when you go out at night. But if we look at those fuzzy stars with a professional telescope, we can actually tease out more detail. So I'm going to show you something when we look at that star, which already looks a little bit red in this image, but we're going to look at it in great detail with what the Hubble Space Telescope sees. So Hubble doesn't see this wide swath of the sky. It only sees a small field of view, but in greater detail. So when we look at that reddish star with Hubble, we see this. And it's actually a nebula, one of these clouds that is lit up by not one, but several stars, massive stars that have formed in there. And one of those massive stars in particular has enough energy to ionize the surrounding gas, give it the colors that we see. And again, it shows us that star formation is active. My own research has, at least from my doctoral degree and some years after that, was looking at this region with radio telescopes, which see kind of through this foreground lit up part to a much thicker, darker, invisible cloud behind it. This is like a blister in front of a much bigger cloud. And there are lower mass protostars coalescing in that background gas. And so I study that using the tools that let me see into that background cloud and see how the gas is collapsing into filaments and clumps and eventually stars. Now, if you look more closely in this region, though, you actually see that there's some little stars still trying to form within this turbulent, lit-up nebula, and they are accreting material from the surrounding cloud. And that material takes on the form of a disk. So if you look at a couple of these objects, which I've blown up here so you can see them in more detail, you might not have even noticed them before in the image as a whole. You see one of them on the left, and its orientation is kind of face on, and one of them on the right, its orientation is a disk, kind of edge on. They can be in any orientation to our viewing position. And you see that the interstellar object is surrounded by this dark, dusty disk. The diameter of that disk is about, for each one of these objects, is about the diameter of our solar system. And so it turns out that in our epoch of the universe, stars typically form with planetary systems around them. And now we know not only do planets exist, we know they're still forming. These planets outside of our solar system we call exoplanets because they're planets outside of our solar system's planets. Activity. We have planets forming. We can have activity in our own solar system. So here's a planet that formed around our sun, Jupiter. You see it's a gas giant with many beautiful layers of gas and that great red spot, which is a giant storm. We've looked at this over time with telescopes like Hubble over decades, and we see that the weather changes. That storm is shrinking. Other storms are cropping up. And when we look at it with different kinds of light, we get different kinds of information. Remember I told you different kinds of light, different kinds of telescopes and cameras see different kinds of light. That gives us different types of information. So if we point Hubble's ultraviolet detector on this planet, we see something crop up on the top there. That's the aurora, the northern lights, if you will, on Jupiter. So if we watch it over time, those northern lights are dancing around. It's the same thing that's happening on planet Earth for the northern lights. You have sometimes charged particles coming in, sometimes from the sun, hitting the magnetic field around the planet that's anchored in the pole and creating the lit up activity that you see there. We compare that with what we learn from the Juno probe that's right there orbiting in the Jupiter system and taking measurements of the magnetic field and the gravitational field and other things. And so we learn a whole lot more by combining the information we see with a telescope with what we see from the probe and really getting a good handle on what's going on in this active planetary system of Jupiter. And now Webb is showing us with infrared light some of the hazes and the temperature differences of different features in the atmosphere of Jupiter. Old stars are active. When stars are in the prime, like our sun, they are pretty stable, fusing the material, mostly hydrogen in their cores, into the heavier elements and releasing light. But eventually they start running low on that core hydrogen and stars become unstable. Most of them begin to just simply eject their outer atmospheres as part of this process. So that's what's going on with an old star buried in the middle of this nebula. And in this case, the material is being kind of channeled out into a bipolar fashion that looks like butterfly wings. So it's called the Butterfly Nebula. It's beautiful in that sense, but it's also very important because these old stars, as they eject their material, they're ejecting the heavier elements that were forged during all those years of fusion, and that can include helium, but also oxygen and iron and carbon, and then those heavier elements are taken up into the next generations of stars that form in these interstellar clouds. The most massive stars actually get so unstable that they explode when they start running out of inner fuel. So this is the leftover remnant of a supernova explosion where the innards of a star are being expelled out. The explosion happened about 1,000 years ago, and people watching the sky from different parts of the world, including China, took note of a star that brightened up all of a sudden, and we can still follow the debris as it moves out. There's a leftover core of that star, a neutron star buried in here, and the different colors represent the different types of elements that were forged in the star or forged during the explosion, expelled into the interstellar medium, mixed in with the interstellar gas, and then available to be incorporated in the next generations of stars and their planetary systems. This is really important because stars are the factories, excuse me, that make the heavier elements that we need for our era of the universe, where we have a star that has heavier elements in the mix, and we have planetary systems that formed around the star needing those heavier elements to form dust and rocks and planets. Our solar system is not a first generation star. So I think of these stars as like God's factories. What an amazing way to produce the heavier elements we need for our era of the universe. The activity continues. Galaxies as a whole can be very active, and one way we know throughout the universe's history is that galaxies have actually merged together. While most of them seem to be moving apart from each other with the expansion of space, if there are galaxies close enough to each other, their mutual gravitational pull will be the dominant force and will pull them together, and that merging can create a galaxy that's bigger than the two or more that came together. And it can also incite a lot of turbulence that can actually foster more of this vigorous star formation in the nebulae within the galaxy. So here's a couple more that are farther along the way in their merging. So how do we respond to this activity that we see going on in the universe? I haven't even mentioned about things going on around these black holes at the galaxy and beyond scale and so forth. We respond, I think, in lots of ways, but two ways can be, again, a sense of wonder and awe. But I hope we also want to explore and find out more. What's going on in the universe as a whole? What's going on in our own solar system? Let's learn more. And in our own solar system, we've been developing probes, such as this one, Perseverance, a rover on Mars that looks almost like a little friendly droid, doesn't it? But anyway, it's driving around, taking pictures, sending back information as we explore Mars in ways that humans cannot yet do, but should be able to do, hopefully, before too many more years go by. There's one of the first images from the rover on the surface of Mars. And it's very interesting that Mars is basically a cold, dry desert now. But if you dig down just a little bit in the soil, you find frost. You can look around and find lake beds and sea beds. And you know that that Mars used to have a very different kind of surface environment. We want to know why that's changed. Exploration has been enhanced by technology, as I mentioned. So I put this in here to show you pictorially how that can work. This is from the inside of the space shuttle on the last servicing mission that astronauts did to the Hubble Space Telescope. And one of the astronauts, an astronomer, John Grunsfeld, brought with him something. So in the background there, through the window, you see the Hubble telescope. For several days, the telescope was connected to the space shuttle in orbit around the Earth while the astronauts did their servicing tasks on the telescope. Inside, in front there, you see a model of Galileo's telescope from 400 years ago. And this was brought up by astronaut Grunsfeld. And you can see this juxtaposition, how 400 years of optics and technology development have given us the gift of understanding the universe in ways we would never have dreamed of before. But it was Galileo's first innovative use of the telescope to do systematic observations of space and record what he saw. That led to what we might call the modern revolution in observational astronomy and the impetus to improve the optics and the technology to keep exploring the universe. All right, the universe is enormous, and I'm not going to throw tons and tons of numbers at you, but we know in our own galaxy there are something like 200 billion stars, give or take 100 billion, something like that. Sometimes it's hard to get a sense of this, so let me pull back. This is a picture from a telescope on the ground looking toward the center of our own galaxy. Remember the picture of our own galaxy from inside the artist's conception, and as you look along the plane of our galaxy, you see in the lower left a lot of dust and a lot of stars. And as we look at some of those big starry things toward the center of our galaxy, we notice that some of them are not individual stars. So we're going to zoom in now from this wide field of view and zoom in toward one of these. Oh, I hope this works. It worked in the practice room. Oh, here we go. All right. This is the constellation Centaurus. We're zooming in to one of those, what looked like a star, and we're transitioning over to the picture from another telescope that sees more detail. And you see it's actually a cluster. And then we're transitioning over to the Hubble image, which gives us the individual stars. So context matters, right? You need to know whether you're seeing a tiny thing within something big or where it fits in. And let's see. Some people like to see that again. I don't know. Okay. I don't know if it's going to let me do this again. All right. It's complaining. Oh, okay. All right. I don't like that constellation because it's violent. Think of a different one for those stars. Okay, we're zooming in one of those stars. Oops, we transition over to another telescope and we see that that's actually a globular cluster of stars. And then we transition over to the high precision but small field of view of Hubble and see the individual stars. So context matters. Galaxies can contain, as I mentioned, hundreds of billions of stars and a lot of the dark matter within. But now we know there's a lot of galaxies. And we've only known this for the last century, you know, so we live in a privileged time. This is my favorite picture from Hubble, the ultra deep field where Hubble was pointed in, again, a small field of view in the sky, but where there weren't any nearby stars, and just collecting light for several days to see what faint light would show up. And this is the result. It's this collection of thousands of smudges of light, and each of these are not individual stars in our own galaxy. There's a couple of foreground stars from our own galaxy, but for the most part, every little smudge of light here is another galaxy, and each one of them can contain hundreds of billions of stars. And if you look in any direction of the sky, you see pretty much the same thing. Webb is taking this to a new height, if you will. Here's Webb's deep field, first one. There'll be lots more coming out from Webb. And you see the foreground stars with the big diffraction spikes, but all the other little smudges of light are background galaxies, each containing hundreds of billions of stars. If you could get far away from our Milky Way and look back at the sky, you'd see all this, and you'd see our Milky Way as one of these little smudges of spiral smudges with our 200 billion stars and our own solar system buried within. We live in an enormous universe. How do we respond to this? I hope with a sense of awe and a sense of humility about where we are in this universe. The universe also holds mysteries. Looking back at that Webb deep field, if you look carefully, you'll see some kind of weird sort of arc-like shapes buried there between and around the galaxies. That's actually light from background galaxies behind some of these foreground galaxies that are in a cluster. There's so much matter in these galaxies, especially clusters of matter, that they can actually warp space-time itself with their gravity. And most of the matter is in this unseen dark matter, but we know it's there because of its gravitational effects. So astronomers look at the weird kind of arcs and magnification of background galaxies that we see in fields like this to understand where the dark matter is distributed in the foreground cluster of galaxies that's doing the lensing. It's called gravitational lensing. We don't really know what dark matter is, but we're understanding better where it is and what it does and how much there is. You heard some of that yesterday. And physicists are working very hard to try to understand what it is. How do we respond? Well, we respond, I hope, with curiosity and with more exploration. You know, a few years ago, by few, I mean within the last couple of decades, we have come to recognize that the universe, the expansion of the universe, is actually accelerating. You heard some of that yesterday, too. What is this dark energy that's actually accelerating the expansion rate of the universe? Nobody would have said that to me when I was in graduate school. It was always going to collapse back in on itself or at least slow down forever. So we need to know more. And we are discovering more. We've discovered now gravitational waves. These are portals of information traveling across the universe, but they're not electromagnetic waves. They're distortions in space-time, predicted by Einstein, now detected. This is the detection of a gravitational wave from the LIGO detector that came from merging black holes. This is a simulation on the left because we can't see to that detail, but the right, the predicted signal of what you would see if two black holes merged in the distant universe and sent a pulse of disturbance across space-time, we have picked up, and we're picking up more and more of these signposts of other energetic activity in the universe. We call this kind of work comparing what we see with telescopes that we're used to with now these more exotic gravitational wave detectors or even particle detectors. We call it multi-messenger astrophysics because we're getting messages from different kinds of information, and it's a very hot topic in astronomy and astrophysics now. You may have seen the news headlines. These big facilities are now starting to even image black holes. And I hope you're wondering to yourself, well, how in the world can you image a black hole? Because isn't the whole point that the black hole swallows all the light? And that's correct. Black holes are very compact portals of matter, but that distort space-time, so much so that right in the interior of the black hole region of influence, light cannot even escape. But right around the edges, as materials kind of accreting into that region and orbiting around, it can be very bright as that material falls in. And so that's what can be imaged here now, and it's quite exciting. All right. Next area, the universe is progressive. And I don't necessarily mean that in a political way. In fact, I don't mean it in a political way. I mean, we're part of a changing universe. And the reason I use the word progressive is that the universe seems to have become more hospitable to life over time. So here's our Hubble Deep Field again. But remember that some of these galaxies are closer to us than others. And so it's taken longer for the light to get to us from the more distant galaxies than from the ones closer to us, right? So we're actually seeing the ones that are farther away, we're seeing them as they were earlier in the history of the universe. And so this little fly-through animation helps us look at those galaxies that we think are closer to us. It's hard to measure distances, but it can be done. And we see the familiar sort of spiral structure galaxies, but as we move out to the more distant galaxies in the image, we're seeing them as they were at an earlier epoch of the universe, sometimes millions of years in the past. And as we go farther out, we're seeing galaxies from billions of years in the past. Now, we think that the universe, from several lines of evidence, is about 13.8 billion years old. And so we're now seeing galaxies to within that first 0.8 of the 13.8 billion year history of the universe. And I hope you're noticing that these early galaxies look different than the ones at the beginning. They're smaller, they are not that beautiful spiral shape, and we're seeing fewer of them. It's not that there are fewer of them in the early universe, it's that they are redshifted in their light. As the light has traversed the universe, through the stretching universe, it has become reddened to the point where Hubble cannot pick it up. But the Webb telescope is seeing some of those earliest galaxies. So we can look at these from different epochs of time. Astronomy gives us the privilege of being a time machine, and we can see that the galaxies from 10 billion years ago look different than the ones from 3 to 7 billion years ago, which look different from the ones closer to us. And their compositions are different too, because galaxies like our own have had time for generations of stars to come and go, providing the heavier elements that we need. So how do we feel about this? Well, I hope we respond with gratefulness that the universe has had the time and the processes to create the heavier elements that allow stars like our own with planetary systems to form in our own epoch. And this has provided conditions for life to thrive on at least one planet. So this is wonderful. And for some, it looks like a sense of purpose to the universe. So the universe is fruitful. It is, in fact, producing planetary systems. This is an artist's conception, but of a real system that's been detected by the Kepler telescope of a star, in this case with 6 tightly orbiting planets. Exoplanets are a hot topic now. In fact, we know the nearest star system to our own, the Alpha Centauri system, has a little baby star in it called Proxima Centauri on the lower right, and it seems to have a planet in its habitable zone. So you can bet that we'll be studying these systems very heavily with current and future telescopes. And of course, artists can't help but try to imagine what it might look like if you were on that planet, Proxima Centauri b, looking back toward the parent star. Could there be life? There's a whole different talk I could give on, what could that life be like, and what, could the life have a sense of right and wrong? Could they have the moral problems we have? That's, a topic that's actually been discussed for centuries, and you might enjoy reading some of that literature, including the writer C.S. Lewis's Space Trilogy, where he speculates on the spiritual state of possible life elsewhere. How do we respond to this? Well, again, with awe, but I think also gratefulness that we live in a universe that has developed in a way that is allowing life to exist, and even life like our own to contemplate itself. All right, I would be remiss to not mention that the universe is also troubling, vast in a way that's mind-boggling, and even dangerous. What do I mean by all this? Well, you can look at this information and feel a sense of insignificance. Many people do. You can also look, just with the physics, at the long-term future of the universe, and it looks grim, because the universe is active now, but if the universe keeps expanding forever and cooling off and dying out and darkening up, doesn't look very hopeful. Now, we have other information. We have other input beyond just the physical science information. We know that we've been promised, those of us who share the faith that Christ will return and there'll be a renewed heavens and earth, a new heavens and earth, a new order of things. But just from the science alone, we don't get that kind of hope. And then there are just natural disasters. I watched a film this past week at the American Astronomical Society meeting where one young astronomer was brave enough to let her story be known, where she and her family were walking along the beach and a very natural phenomenon, a wave from the ocean came up, and it was a rogue wave. It was much bigger than any of the other waves in its surroundings and actually washed her family away. Just a horrific tragedy. So we can't just look at the universe and say, oh, it's all beautiful and wonderful and feel good. There are difficult things to grapple with, and there are theologians in this room who have grappled with this component of studying the heavens. We ask, are we significant? And we don't know. So we respond to some of these thoughts with concern, sometimes with fear, sometimes with bewilderment. But I hope for those of us in the faith, we also respond with trust, for trusting God for the things we don't understand based on the things that we do understand and have experienced and have been told. Blaise Pascal had a sense of distress when he considered the short time duration of his life swallowed up in the eternity before and after and this tiny little space he filled. He said, why am I here and not there? Who's put me here? By whose order and direction have this place and time been allotted to me? And he responded to himself by saying, the eternal silence of these infinite spaces frightens me. Even Carl Sagan said, who are we? We find that we live on an insignificant planet of a humdrum star, lost in a galaxy, tucked away in some forgotten corner of the universe. Do you ever feel that way? That's a reasonable response if you look at significance only in terms of spatial position and time, but that's a philosophical choice. And I prefer the psalmist from this psalm who was looking up at the night sky and wrote, O Lord, our sovereign, how majestic is your name in all the earth. When I look at your heavens, here's that insignificance, the work of your fingers, the moon and the stars that you've established, what are human beings that you're mindful of them? Who are we that you care for us? But then the psalmist went on and said, hey, wait a minute, but you've made us just a little lower than yourself, than God, and crowned us with glory and honor. You've given us dominion over the works of your hands. You've put all things under our feet. Now the psalmist knew they couldn't manipulate the stars with his hands, but I think in this sense the dominion means understanding, and I would put science under that realm of dominion, science is a gift. So perhaps our significance is apparent not from our place or our time span in the universe, but from the fact that we exist at all, a product of a universe, or possibly a multiverse, that's evolving toward life, and our consequential ability to contemplate good, evil, and our place and purpose in the universe. All right, I'm told that I have a little over 2 minutes left by my little clock here, so we're going to try to get through all the rest of the meaning and purpose of the universe in 2 minutes. There are many people who've thought about these things greatly. I refer to you to the late Sir John Polkinghorne, who was a physicist, who then became an Anglican priest and has written many helpful books on science and theology. He says they're both concerned with truth. In consequence, they complement each other rather than contrast each other. Of course, the two disciplines focus on different dimensions of truth, but they do share a common conviction that there is truth to be sought. And I think that's a very insightful observation. I'd say the universe is beloved. I didn't want to skip over that. We're told that God so loved the world that he gave his one and only Son, that whoever believes in him shall not perish but have eternal life. The world here may have been meaning the world of society, but in any case, we are told that God has demonstrated not just the powers of creation, but the intention of individual love. And this most powerful passage, people come to me often after I give science talks and say, well, what do you think came first? The Big Bang or some kind of quantum field or something else? What's first? Where did everything come from? And that's a perfectly valid physical question to ask of what science can address. But Scripture tells us that there's a different answer beyond science that really matters. It's not just forces of nature that are the most important. The most important beginning is a person. In the beginning was the Word, and the Word was with God, and the Word was God. And that Word became flesh and made his dwelling among us. And we've seen his glory, full of grace and truth. There's, to me, no more powerful passage in all of Scripture. God is with us, Emmanuel. And what for? Jesus said, I've come that they may have life and have it to the full. We can have a personal relationship with the God of the universe. Think about that as you pray next time. We respond with service and love. We make what we learn a blessing to others. Here's a student at the Maryland School for the Blind touching images from space that have been tactile encoded so that galaxies feel different from stars and planets. And these students in the classroom I spoke to were every bit as excited about what they were exploring through touch as many of us are by what we explore with our eyes. Here's a colleague of mine, Gladys, from my scientific workplace, but she is a Christian and has used her vacation time to go visit orphanages. And in this case, the children here in another country had lots of food and clothing, and so they were blessed in that sense. They were children of martyrs, so they'd had trauma in their lives. But what they wanted to hear from Gladys was about space. That people are inspired to hear about what we're learning in the universe on the large scale or even what we're learning on the small scale. Science can be used to uplift spirits. And I like this article you might want to look at from the Vatican Observatory's webpage by, if I can read that, Christopher Graney, if I can read that right, on faith, science, and a big parade. It doesn't have to be always a discussion of, where is there controversy? Is there controversy? Is there compatibility? Let's talk about joy and celebration. So the universe, I hope you will leave here realizing that the universe is awesome, filled with things seen and unseen, activity abounding, lots more to learn. We, scientists and people of faith, and these are overlapping groups, speak a common language, says Dr. Nancy Edelman, professor of psychology at Catholic U. She says we speak a common language which is awe and wonder about the world at large, and we can meet on common ground and consider that common interest. I'd say amen to that. Finally, we respond, I hope, with praise. Here's the space window at the National Cathedral in Washington, D.C., inspired by space exploration. And the light coming to us through what we learn with space exploration can be inspiring. The universe inspires. I hope it also inspires us to take care of our home planet. Looking back from the space shuttle after the last servicing mission, we're seeing, for Hubble, we see the sun rising up behind the limb of the Earth. And you see that very wispy blue arc there. That's our atmosphere. Beautiful, fragile atmosphere of our home planet. Let's be inspired as we look at the universe as a whole to take care of our home planet as good stewards of this garden we've been given. If you want to learn more about the relationship of science and faith and through books, organizations, websites, I've put this together, not so much for you here in the room because you can't read all this, but for those of you watching online, you can take a quick screenshot. But these are some of my favorite organizations and books and websites in addition to Word on Fire, where you can find fellowship or interest, whether you're interested in literature or science or ethics. Organizations like the Society of Catholic Scientists or the American Scientific Affiliation, BioLogos, and the Faraday Institute for Science and Religion. So, in closing, and I'm 3 minutes over, praise God. Let's praise God for the universe. And let's praise God for the gift of science that allows us to explore and understand the wonders of creation. Amen? Amen. Amen. Thank you very much.